Okay guys, we're gonna keep going along with those equations we did yesterday, that slope-intercept form. So a linear relationship, it's got the word line in it, so think of a straight line. Just like we did yesterday, a linear relationship is an equation whose graph is a line. One way to graph a linear equation is to make a table of ordered pairs. So remember, slope of a line, k or m, equals the change in y over the change in x. K is the change in y over the change in x. Or, like yesterday when we graphed it, the rise over the run, the vertical change to the horizontal change. Okay, so today we're still going to be dealing with these equations, and like I said yesterday, that kind of is your solution. In this case, we can check it. So we can check to make sure that a pair of ordered pairs will work with this equation. So first one, graph y equals 3x plus 2. Remember, this is your m, or your slope, and this is your b. So select any four values for the independent variable x. For the table below, the values -1, 0, 2, 1, this should be 1, and 2 were chosen. Substitute or plug in these values for x to determine the dependent variable y. So what that means is this y equals 3x plus 2, they've put that here. So this is the same expression we're going to use each time, and we're going to plug in this x value into the equation to see what we get for y. So then we can have an ordered pair and we can plot that point on our graph. So they plug in -1 for x plus 2. When we solve for that, we get -3 plus 2. Remember, -3 plus 2, different signs, subtract. So we get -1. So then our x and y, our new point would be -1, 1. And we could plot that on the graph. Same thing here, they plug in 0 for the x. So 3 times 0, 0, plus 2 is 2. So 0, 2 is our new ordered pair. Same thing here, they plug in 1 for x. So 3 times 1 is plus 2 is 5. So 1 comma 5 is our new ordered pair. We could plot that on the graph. And then we try 2. So 3 times 2 would be 6, plus 2 would be 8. So our x value is 2 and our y value is 8. So the ordered pairs for x and y are -1, -1, 0, 2, 1 and 5, 2 and 8. By graphing these ordered pairs, we create the graph y equals 3x plus 2. So yesterday we were kind of graphing this without having specific points. This way we can kind of see and we can get those specific points, and then you're just plotting those, and that's a little bit easier. Down here at the bottom, make a table and graph each linear equation. So y equals x minus 2. So they've already filled in the top part for us. X minus 2, that's our expression we're going to use. And our x values. Anytime you're trying to see your points, always use these, -1, 0, 1, and 2. It's the easiest way to go about that. So then let's plug in -1 for x. So -1 minus 2. And that's going to give us -1 minus 2 should be -3. So then our new ordered pair, -1, -3. Same thing here. Plug in 0 for x. So 0 minus 2. 0 minus 2, and that gives me -2. So my new ordered pair would be 0, -2. Then I want to plug in 1 for x. So 1 minus 2. Different sign, subtract, take the sign on the bigger number, so -1. That makes my new ordered pair 1, -1. Same thing here, plug in 2 for x, so 2 minus 2 is 0. So my new ordered pair is +2 and 0. And we can go to the graph and we can plot those points. -1, -1, 2, 3, 0, -2, 1, -1, and 2, 0. Okay. Same thing over here. Our equation is y equals -x, which just means -1x. So we don't even have a y, or we don't even have a b, I mean, to add on to. So we can plug in -1 for x. or think of it as -1 times -1, which would be +1. So now your new ordered pair, -1, +1. Same thing here, -1 times 0, that gives me 0. So 0, comma, 0. Then I've got -1 times +1. So my y would be -1. It's my new ordered pair, 1, comma, -1. And I want to plug in 2 for x, so -1 times +2, -2, new ordered pair, 2, comma, -2. And then take a second and plot those points. So -1, +1, 0, 0, 1, -1, and 2, -2.